At the Global Top Conference NeurIPS 2024, Ilya delivered his first public speech after leaving OpenAI. In just 16 minutes, his speech shook the entire audience. He announced to the world that the era of pre-training is over. Data, much like fossil fuels, is difficult to regenerate. The future of AI lies in developing self-aware superintelligence. Although his speech was brief, and many people may have already watched it, I believe it is necessary for our channel to create an episode about it. Perhaps in a few years we may look back and see this speech as historically significant. But standing in the present, where are we headed next? At the end of November, NeurIPS 2024 announced its Test of Time Award. Ilya and Ian Goodfellow, the father of GANs, were among the recipients. At the beginning of his speech, Ilya first thanked the two co-authors of the paper, Sequence-to-Sequence Learning with Neural Networks, Oriol Vinyals and Kwok Le. He also shared a photo of the three of them during a talk at the NeurIPS conference in Montreal in 2014, 10 years ago. Ilya noted that it was a simpler time. Today, the three young men in that photo have grown into what they are now. He then revisited the slides from their presentation 10 years ago. Their work at that time could be summarized in three key points. 1. It was an auto-regressive model trained on text. 2. It was a large neural network. Third, it utilized a large-scale dataset. At that time, they proposed a concept called the deep learning hypothesis, which stated that if you had a 10-layer large neural network, it could complete any task a human could do in a fraction of a second. Why emphasize completing tasks in a fraction of a second? If you believe in the basic assumption of deep learning, that artificial neurons are similar to biological neurons, and if you also believe that real neurons operate slower than the speed at which humans can complete tasks, then as long as there is one person in the world who can complete a task in less than a second, embedding the connections of a 10-layer neural network into your artificial neural network should enable it to do the same. This was their motivation. They focused on a 10-layer neural network because, at the time, that was the limit of what they could train. Of course, if they could go beyond 10 layers, they would be able to achieve much more. Ilya then used a slide to describe their main idea. The core point was that if you have an autoregressive model that can predict the next token well enough, it would essentially capture and learn the true distribution of any sequence. At the time, this was a relatively novel idea, although it wasn't the first autoregressive neural network applied in practice. However, Ilya believed it was the first autoregressive network that gave them complete confidence that, if trained well enough, it could produce whatever result they wanted. So they decided to try translation, a task that seems commonplace today, but was extremely challenging at the time. Next, Ilya showed some historical material that many might never have seen before. LSTM. For those unfamiliar, LSTM, long short-term memory networks, were the tools deep learning researchers used before transformers emerged. LSTM can be thought of as a rotated ResNet, but more complex. It included components like integrators, now called residual streams, and involved more intricate multiplicative operations. Ilya emphasized that they used parallelization at the time, but not standard parallelization. It was pipeline parallelization. Each layer of the neural network was assigned to a separate GPU. From today's perspective, this strategy seems inefficient, but they didn't know better back then. Using 8 GPUs, they managed to achieve a 3.5x speedup. It was here that scaling laws began. Finally, Ilya presented what he called the most significant slide from their talk at the time, a slide that marked the beginning of scaling laws. The idea was simple. If you have a very large data set and train a very large neural network, success can be guaranteed. Broadly speaking, what happened later confirmed this to be true. Ilya also mentioned a truly timeless idea, connectionism, which is the foundational concept of deep learning. Connectionism remains at the heart of the field. Connectionism suggests that if you are willing to believe that artificial neurons are somewhat similar to biological neurons, then you will believe that extremely large-scale neural networks don't need to reach the level of the human brain to accomplish nearly everything humans can do. However, it is still different from the human brain because the human brain figures out how to configure itself, whereas neural networks use the optimal learning algorithm and require a data set proportional to the number of parameters. In this regard, humans still have the edge. All the points Ilya mentioned earlier ultimately led to the concept of the pre-training era. This era can be defined by GPT-2, GPT-3, and scaling laws. At this point, Ilya also expressed special gratitude to his former colleagues Alec Radford, Jared Kaplan, and Dario Amodi. This technology has been the driving force behind all the AI advancements we see today. However, Ilya pointed out that the pre-training approach as we know it will undoubtedly come to an end. Why? While computing power continues to grow with better hardware, improved algorithms, and larger clusters, the amount of data is not increasing. This is because we only have one internet. In fact, data can be likened to fossil fuels for AI. They are created in specific ways, and we have now reached the peak of available data. There cannot be more data. That said, Ilya did not mean that data is completely exhausted. The existing data can still support significant progress. However, since we only have one internet, what happens next? Ilya offered the following predictions. First, breakthroughs will occur with intelligent agents. These are AI systems capable of autonomously completing tasks, and they represent the future direction of development. Second, there will be some use of synthetic data, though what exactly this entails remains unclear. However, many researchers are making exciting progress in this area. Finally, there is inference time computation. The most notable example is O1, which comes after pre-training. What should we explore next? Ilya used an example from biology to illustrate his point. He showed a graph that demonstrates the relationship between body size and brain size in mammals. While biology is typically chaotic, this relationship is a rare example of a clear and consistent pattern. From the evolutionary branches of humans and their close relatives, such as Neanderthals and Homo habilis, the scaling exponents of brain-to-body ratios are different. This indicates that in biology, there are indeed precedents for different scaling ratios. Today, what we are scaling is, in many ways, the first thing we know how to scale effectively. Everyone in this field is finding solutions, and we've made incredible progress. Those who were in this field 10 years ago can remember how helpless we once felt. However, those who have entered deep learning in the past 2 years may find it hard to relate to that struggle. Finally, Ilya talked about superintelligence, which is currently recognized as the direction of future development and what many researchers are striving to build. Fundamentally, superintelligence will be entirely different from today's AI. While we now have excellent large language models and chatbots, they still display strange unreliabilities. For example, they often get confused but can still outperform humans in evaluations. Although we don't yet know how to reconcile these inconsistencies, the ultimate goal, or one that will eventually be realized, is that AI will develop true agent-like characteristics and learn to reason genuinely. Reasoning introduces additional complexity, meaning that the more reasoning a system performs, the less predictable it becomes. In contrast, the deep learning systems we know today are still largely predictable. For example, even the best chess-playing AIs are unpredictable for the world's top human chess players. In the future, however, we will face extremely unpredictable AI systems that can understand things from limited data without getting confused. At the same time, self-awareness will also prove to be useful. It is a part of who we are and a part of our world model. When all these features combine with self-awareness, it will create systems with entirely new characteristics and properties, fundamentally different from what we currently have. These systems will possess incredible, astonishing capabilities. Of course, while we cannot predict how or when superintelligence will be achieved, Ilya firmly believes that it will inevitably happen. As for the potential issues such systems might bring, Ilya left it to the audience's imagination. After all, we cannot predict the future, and anything could happen. During the Q&A session, Ilya answered several questions from the audience. The first question was whether there are other biological structures related to human cognition worth exploring. Ilya thought this depends on the level of abstraction we are observing. Many people have long sought inspiration from biology, and it can even be said that biologically inspired AI has already been very successful. For example, deep learning. However, on the other hand, inspiration from biology is quite limited. Using neurons as a model is essentially the full extent of AI's inspiration from biology so far, and more detailed biological inspiration has always been challenging to obtain. The second question was about automatic error correction in models. If, in the future, models can autonomously correct themselves, does that mean they could recognize when they are hallucinating? Ilya gave an affirmative answer, but pointed out that calling it automatic error correction is an understatement. It would be much more profound than that. Nonetheless, at some point, models will realize when hallucinations occur and will develop the ability to correct themselves. Lastly, an audience member from the University of Toronto asked whether large language models could generalize to perform multi-hop reasoning beyond their training distribution. This time, Ilya did not directly answer the question. Instead, he responded with a question. What does it mean to generalize beyond the distribution? What does it imply? What counts as being within a distribution and what counts as beyond it? Before deep learning, people used string matching and n-grams. For machine translation, statistical phrase tables were the norm, and their code complexity was unimaginably high. At that time, if a model memorized something and achieved high scores in a competition, it was considered to be operating within the distribution. But now the standards for generalization have risen significantly. For large models, to some extent, they might indeed not perform as well as humans. However, at the same time, they can undoubtedly generalize beyond the training distribution in certain ways. The above summarizes the main content of Ilya's recent speech. It should be noted that Ilya was one of the early advocates of aggressive scaling, believing that increasing data and computational power to scale up could significantly improve model performance. However, it seems that Ilya may now have new ideas. He has previously hinted that SSI is exploring a completely new alternative method to expand pre-training. Regarding his prediction in the speech, I interpret it as not meaning that pre-training has ended right now, nor that data is entirely exhausted. Rather, for the development of superintelligence, pre-training alone will ultimately not be sufficient. It will eventually come to an end. Of course, there are other prominent figures in the industry who disagree with Ilya's conclusions. Logan Kilpatrick from Google subtly criticized Ilya in a tweet, saying that believing pre-training is over might simply indicate a lack of imagination. Dhruv Batra, the former senior director of the embodied AI team at Meta, also disagreed with Ilya. In his view, humanity's data has not been exhausted. We have only run out of text written by humans. However, the amount of video data we have still far exceeds our ability to process it. It's just that the problem of pre-training in the visual domain has not yet been solved. Furthermore, if we consider the potential for robots in the future to collect massive amounts of multimodal data, such as visual, olfactory, and tactile data, then perhaps data will still be abundant for a long time. What do you think about Ilya's speech and his conclusions? Do you believe pre-training will truly come to an end? Share your thoughts in the comments section.